What if everything we know about landscapes, everything familiar, comforting, even predictable, was just a tiny fraction of what the universe has to offer? Picture a place where the very laws of nature twist into something unrecognizable, where mountains glow with an otherworldly light, and oceans aren't made of water, but of liquid metals swirling under alien suns. These aren't scenes from science fiction, they're real cosmic landscapes scattered across the galaxy, each one a masterpiece of planetary artistry. And today, we're about to embark on a journey to 20 of the most extraordinary among them, places so bizarre and beautiful, they'll make you question everything you thought you knew about worlds beyond our own. Think about the last time you stood in awe of Earth's natural wonders, the Grand Canyon's vast depths, the northern lights dancing across the sky. Now multiply that sense of wonder by 1,000. Because out there, in the uncharted corners of the cosmos, entire planets are sculpted by forces we're only beginning to understand. Imagine a world where it rains glass sideways, where storms rage for centuries, or where the ground beneath your feet is made of solid diamond. These aren't just hypotheticals, they're real places, each with its own story written in the language of geology, chemistry, and physics. And every one of them holds clues, not just about how planets form, but about how strange and diverse life itself might be. This is more than a tour of cosmic oddities. It's a reminder of how small we are and how much there still is to discover. Every time we uncover a new world, we're not just adding to a catalogue of celestial objects. We're rewriting the boundaries of possibility, challenging our assumptions about where life could thrive, and even redefining what habitable means. So let's set aside what we think we know and step into the unknown together. From the molten shores of super-Earths to the frozen plains of rogue planets drifting between stars, each of these 20 landscapes is a testament to the universe's boundless creativity. Ready to see them for yourself? Then hold on tight, because the journey ahead is going to be unforgettable. The Diamond Planet 55 Cancree is a cosmic paradox, a world of unimaginable wealth that would vaporize any visitor instantly. This super-Earth isn't just sprinkled with diamonds, it's likely made almost entirely of them, a glittering nightmare where the very crust could be one massive gemstone. Imagine standing on a surface where the rocks beneath your feet aren't gray and dull, but crystalline structures stretching to the horizon, refracting the light of its blazing parent star into prismatic shards. With temperatures hot enough to melt steel, the diamonds here aren't the clear, sparkling gems we know. They're superheated, possibly forming vast liquid carbon seas that churn beneath a thin atmospheric haze. What created such a bizarre world? Astronomers believe 55 Cancree was born in a carbon-rich system, where an overabundance of this element allowed it to form a core unlike any rocky planet in our solar system. Over billions of years, crushing pressures transformed that carbon into dense diamond structures, layer upon layer, until the planet became a celestial treasury. But here's the twist: this diamond might not be forever. Some researchers suggest the planet could be slowly evaporating, its glittering surface boiling away into space under the relentless heat of its sun. And yet, the real wonder isn't just the diamonds, it's what they tell us about planetary diversity. If a world like this can exist, what other impossible-seeming landscapes might be out there? Could there be planets with sapphire skies or emerald valleys? The universe has already shattered our expectations once. Who knows how many more cosmic jewels are waiting to be discovered? If the Diamond Planet showed us a world of impossible riches, Kepler 10b reveals a realm of endless fire, a place where the very ground you'd stand on is an ocean of liquid rock. This isn't just a planet with active volcanoes. It's a world made of them, a superheated nightmare where the surface temperature exceeds 2,500 degrees Fahrenheit, hot enough to vaporize iron. Orbiting 20 times closer to its star than Mercury does to our Sun, Kepler 10b is tidally locked, meaning one side forever faces the inferno while the other lingers in perpetual darkness. The day side isn't just dotted with lava flows, it's a single, glowing sea of molten rock, stretching across the entire hemisphere without a single solid patch to interrupt it. But here's what makes this landscape truly alien. Without a substantial atmosphere, the lava doesn't behave like it does on Earth. At the edges of the day side, where the unbearable heat gives way to the freezing void of space, the lava doesn't just cool, it sublimates, transforming directly from liquid into a metallic vapor that swirls in ghostly plumes before raining back down as molten droplets. Could anything survive here? Almost certainly not in any form we'd recognize. But Kepler 10b isn't just a dead world, it's a laboratory. By studying how rock behaves under such extremes, scientists can piece together the violent early history of our own planet, when Earth's surface might have looked eerily similar. And if lava worlds like this are common, it forces us to reconsider what habitable even means. Maybe life doesn't need oceans of water. Maybe, somewhere in the universe, it's found a way to thrive in oceans of fire. Now, let's escape the heat and journey to a world where the cold is so absolute, it defies imagination. From the scorching lava fields of Kepler 10b, we now plunge into the frozen heart of Ogle 2005 BLG 390 LB, a world so cold it makes Antarctica feel like a tropical getaway. This isn't just a chilly planet, it's a cosmic deep freeze where temperatures hover around -220 degrees Celsius, cold enough to turn the very air into a brittle solid. Orbiting a faint, dying star 28,000 light-years away, this super-Earth exists in perpetual twilight, its surface a wasteland of glaciers not made of water, but of frozen nitrogen and methane that crack and shift like alien tectonic plates. What makes this iceball planet fascinating isn't just its extreme cold, it's the secrets that might lurk beneath its icy shell. With an atmosphere thinner than Earth's outermost vacuum chambers, the surface is utterly inhospitable. But dig deeper and things get intriguing. Some researchers speculate that geothermal heat from the planet's core could maintain hidden oceans beneath miles of ice, much like the subsurface seas we suspect exist on moons like Europa or Enceladus. And where there's liquid water, even trapped in the darkest depths, there's always the tantalizing question, could life find a way? The idea isn't as far-fetched as it sounds. On Earth, extremophiles thrive in places we once thought barren, from volcanic vents to Antarctic ice sheets. If organisms can survive there, why not in the buried oceans of a distant super-Earth? Of course, any life here would face challenges beyond imagination: crushing pressure, eternal darkness, and chemical soups of ammonia and methane. Yet the mere possibility keeps astronomers riveted, because Ogle 2005 BLG 390 LB isn't just a frozen relic. It's a reminder that habitability might hide in the last places we'd think to look. Now prepare for a world where the sky doesn't just rain water, it rains glass. If you thought sideways rain on Earth was inconvenient, imagine a storm where the raindrops are molten glass, and they're moving faster than a bullet. Welcome to HD 189733b, a cobalt blue nightmare where the sky isn't just hostile, it's actively lethal. This gas giant, glowing like a sapphire under the glare of its parent star, hides a secret beneath its serene appearance. Winds that scream across the planet at 5,400 miles per hour, carrying with them a hail of superheated silicate particles. As these particles rise and cool in the upper atmosphere, they solidify into tiny shards of glass, only to be whipped sideways in a relentless, glittering barrage. What creates such a violent spectacle? The answer lies in the planet's extreme temperatures soaring above 900 degrees Celsius and its peculiar composition. Unlike Jupiter, where clouds are made of ammonia and water, HD 189733b's atmosphere is rich in silicates, the same minerals that form glass on Earth. But here, they don't just form delicate grains of sand. They're vaporized by the intense heat, then condense into microscopic daggers that swirl in a perpetual storm. The planet's striking blue hue isn't from oceans, as you might expect, but from the way sunlight scatters through this silicate haze, creating an eerie, beautiful illusion of calm. Standing on this world would be impossible, but if you could, the experience would defy all logic. Picture a horizon where the sky doesn't just rain, it attacks with glass shards slicing through the air at speeds 7 times faster than a jetliner. The sound alone would be deafening, a relentless roar of wind and collision. And yet, for all its fury, there's a strange artistry to this chaos. The same forces that make the planet deadly also paint it in dazzling shades of blue, a reminder that even the most violent corners of the universe can harbor unexpected beauty. But HD 189733b isn't just a cosmic curiosity. It's a window into how exotic weather systems operate beyond our solar system. By studying its atmosphere, scientists can unravel the mysteries of wind patterns on gas giants, helping us understand everything from Jupiter's Great Red Spot to the hurricane-like storms on distant exoplanets. And it raises a tantalizing question. If silicates can form glass rain here, what other bizarre precipitation might exist out there? Diamond hail, metal snow. The universe, it seems, has a flair for the dramatic. Now, let's trade the chaos of glass storms for a world where the landscape defies gravity itself, a planet with mountains so tall they pierce the boundary of space. After witnessing the fury of glass storms and frozen wastelands, let's set foot on a world where the mountains defy not just height, but imagination itself. Olympus Mons isn't just a volcano. It's a titan, a geological monument so vast it would stretch from the ocean floor to the edge of space if placed on Earth. Standing 16 miles tall, this Martian behemoth makes Mount Everest look like a foothill. Its summit so high that if you stood there, the thin air would offer a view few places in the solar system could match. The curvature of Mars itself, a rust-red horizon bending away beneath your boots. What makes Olympus Mons so staggeringly large? The secret lies in what Mars doesn't have: tectonic plates. On Earth, shifting continents constantly recycle the crust, preventing any single volcano from growing unchecked. But Mars, frozen in geological stillness, allowed lava to pile up in the same spot for billions of years, layer upon layer, until it created a mountain wider than the state of Arizona. Its slopes are deceptively gentle, rising just 5 degrees on average. A hike here would feel less like climbing and more like walking up an endless, ancient ramp. Yet the scale is incomprehensible. The caldera at its peak is 50 miles across, large enough to swallow entire cities whole. But here's the most haunting detail: Olympus Mons might not be dead. While its last eruption likely occurred millions of years ago, Mars's volcanic history suggests it could awaken again. Imagine the spectacle: a fountain of molten rock erupting in slow motion, with no atmosphere to scatter its glow, painting the black sky with silent, fiery streaks. Even dormant, it stands as a reminder of how planetary forces shape worlds in ways we're only beginning to understand. Now, let's leave this quiet giant behind for a moon where the landscape doesn't just sit still, it erupts, spewing geysers of ice into the endless dark. From the towering heights of Olympus Mons, we now descend into the realm of ice and mystery: Saturn's moon, Enceladus. a world that looks like a frozen marble but hides a secret beneath its shimmering shell. At first glance, this tiny moon seems inert, its surface a cracked mosaic of ice reflecting the distant sun's weak light. But peer closer and you'll witness something extraordinary. Geysers taller than skyscrapers, erupting from deep fractures in the ice, their plumes of water vapor and organic molecules glittering like cosmic fireworks against the blackness of space. These aren't just random eruptions, they're the breath of a hidden ocean, a vast liquid expanse trapped beneath 20 miles of ice, yet somehow bursting through to the surface with astonishing force. What makes these cryovolcanoes so remarkable isn't just their beauty, it's what they carry. When NASA Cassini spacecraft flew through these plumes, it detected salts, silica, and even simple organic compounds, the chemical building blocks of life. The ocean below isn't a stagnant pool. It's likely heated by tidal forces as Enceladus orbits Saturn, its core flexing like putty under the gas giant's gravitational pull. This constant motion could create hydrothermal vents on the ocean floor, similar to those on Earth where life thrives in utter darkness, fueled by chemical energy rather than sunlight. Could the same be true here? The possibility is tantalizing enough that Enceladus has become one of the top targets in the search for extraterrestrial life. But the real magic lies in the spectacle itself. Picture standing on Enceladus's icy plains, where the temperature hovers around -200 degrees Celsius. Above you, Saturn's rings stretch across the sky like a celestial bridge, their pale glow illuminating the geysers as they arc into the void. The plumes don't fall back as rain in this low gravity, they escape entirely, contributing to one of Saturn's outermost rings. It's a water cycle unlike any other, a loop of destruction and creation where a moon's hidden ocean feeds the rings of its parent planet. Yet for all we've learned, Enceladus still guards its deepest secrets. How old is its ocean? How complex could its chemistry be? Future missions aim to answer these questions, possibly even sampling the plumes for signs of microbial activity. Until then, this tiny moon remains a paradox, a world both frozen and dynamic, isolated yet connected, a reminder that even in the coldest corners of the cosmos, the ingredients for life might be waiting. Now, let's journey to a world where the ground isn't just solid, it's alive, shifting like a slow-motion sea beneath your feet. The shifting dunes of Titan don't just move, they whisper secrets about a world that feels both hauntingly familiar and profoundly alien. Saturn's largest moon is wrapped in a thick, orange haze, a nitrogen-rich atmosphere where methane clouds drift and rain down not water, but liquid hydrocarbons. And beneath this eerie sky, the landscape ripples with dunes taller than the Great Pyramid, their dark grains not made of silica like Earth's deserts, but of organic compounds as fine as coffee grounds. These aren't static monuments, they're alive, creeping across Titan's surface at a glacial pace, reshaped by winds 10 times weaker than Earth, yet still powerful enough to sculpt waves that stretch for hundreds of miles. What makes these dunes so extraordinary isn't just their size or composition. It's how they mirror Earth's deserts while obeying rules written in an entirely different language. On our planet, sand dunes form through the interplay of wind and silica. On Titan, the grains are likely a mix of benzene and other hydrocarbons, their surfaces sticky with organic goo that clumps together in ways sand never could. The result, dunes with sharp, cresting ridges, their dark slopes absorbing what little sunlight filters through the haze, making them some of the most striking features in the solar system. And just like Earth's deserts, they are bordered by river valleys, except these channels are carved not by water, but by liquid methane flowing in slow, viscous currents. The Huygens probe gave us our only close-up of this surreal terrain when it landed in 2005, transmitting images of rounded pebbles strewn across a damp riverbed, their shapes hinting at erosion by liquids we'd normally consider gases. But the real mystery lies beneath Titan's surface. Scientists suspect a vast subsurface ocean of water and ammonia hidden below layers of ice and organic sludge. Could this buried sea, combined with the moon's rich chemistry of methane and nitrogen, create conditions ripe for life? It's a tantalizing thought. After all, Titan's atmosphere is a frozen snapshot of the primordial soup that might have once existed on Earth before life emerged. Yet for all its Earth-like qualities, Titan remains utterly alien. The very air smells like a petroleum refinery, thick with organic molecules that would be toxic to us. The cold is so intense, minus 180 degrees Celsius, that water ice becomes as hard as granite, and methane takes on the role that water plays on our planet, cycling between rain, rivers, and evaporation. Even time moves differently here. A single Titan day lasts 16 Earth days, meaning the winds that shape those colossal dunes have an eternity to work their magic. This moon isn't just a curiosity, it's a laboratory. By studying Titan, we're glimpsing how chemistry can mimic geology under the right conditions, how landscapes can form without a single drop of water, and how the building blocks of life might assemble in environments we once thought barren. It's a reminder that nature's playbook is far thicker than we imagined, with pages written in methane and benzene waiting to be read. Now, let's leave this slow-motion world behind for a place where time itself seems to stand still, a planet bathed in eternal daylight, where the sun never dips below the horizon. Gleiser 581c is a world of extremes, a planet forever caught between fire and ice. Unlike Earth, where day gives way to night in a predictable rhythm, this place knows no such balance. One hemisphere bakes under the unblinking gaze of its red dwarf star, temperatures soaring high enough to melt lead. The other side is a frozen wasteland, plunged into perpetual darkness so deep that even the air itself might freeze into snow. But between these two inhospitable realms lies a sliver of possibility, a twilight band where conditions might, just might, allow for something extraordinary. Picture standing in this narrow habitable zone where the sky never changes. On one horizon, the sun hangs motionless, a permanent crimson beacon too close to ever set. Turn the other way and you're met with an endless starry void, the ground beneath you growing colder with every step. The contrast is staggering, a planet where you could literally walk from a desert into an ice age within a matter of miles. Yet in this razor-thin borderland, the temperature might be just right for liquid water to pool, for clouds to form, even for life to take root. What would it be like to live here? Any civilization would face challenges beyond imagination. Without a day-night cycle, weather patterns would be locked in place, creating permanent jet streams howling between the hot and cold sides. Plants, if they existed, might grow sideways, their leaves angled toward the eternal sun, while creatures could evolve to migrate with the shifting thermal gradients. And yet, the most haunting question remains, could intelligence arise in such a fragile equilibrium? Or would the constant struggle for survival snuff out complexity before it could flourish? Gleiser 581c isn't just a scientific curiosity, it's a test of our assumptions. For decades, we've imagined alien worlds as Earth-like oases, but this planet forces us to think differently. Life, if it exists here, wouldn't just adapt to harsh conditions. It would thrive in a reality where the very concept of home is a knife's edge between two hellscapes. And that's what makes tidally locked worlds so fascinating. They're not just oddities, they're mirrors, reflecting back how narrow our vision of habitability really is. Now, let's leave this world of eternal contrasts for one where the sky itself is a spectacle, a planet where it rains diamonds, not water, and the clouds glitter with the dust of crushed gemstones. Deep in the swirling blue depths of Neptune and Uranus, a storm of unimaginable wealth rages, but you wouldn't want to catch this rain. These ice giants harbor a secret beneath their turbulent atmospheres: diamond hail, a phenomenon so extravagant it would make even the most lavish earthly treasures seem mundane. Here, where pressures reach millions of times greater than our planet's surface and temperatures soar to thousands of degrees, methane, a simple compound we know as natural gas, shatters into carbon atoms, then reassembles into glittering diamonds. And these aren't tiny gemstones. They could be the size of boulders, even icebergs, falling in a slow-motion avalanche toward the planet's cores. Picture the scene: a darkened sky not of water vapor, but of hydrogen and helium, streaked with swirling storms the size of continents. Deep below, the atmosphere thickens into a superheated ocean of electrically conductive water and ammonia, a sludge-like fluid where the very laws of chemistry twist into something alien. As methane descends through this oppressive realm, the crushing pressure splits its molecules apart, freeing carbon atoms that are then squeezed into crystalline perfection. The diamonds form in layers, growing heavier until they plunge downward, carving glowing trails through the dense, metallic soup. Some scientists speculate these falling gems might even accumulate into a vast diamond layer around the core, a planetary treasure hoard locked away forever beneath thousands of miles of ice and gas. But the real wonder isn't just the diamonds themselves. It's what they reveal about the universe's capacity for alchemy. If methane can transform into gemstones under these conditions, what other exotic materials might exist in the hearts of gas giants? Could there be oceans of liquid carbon or mountains of solidified helium? The possibilities stretch the imagination, reminding us that the periodic table behaves in wildly unexpected ways when freed from Earth's gentle constraints. Even the diamonds here wouldn't resemble the cut gems in a jewelry store. They'd likely be blackened by immense pressure, their crystalline structures warped into forms we've never seen. And there's another twist: this diamond rain might not be unique to Neptune and Uranus. Similar processes could occur on Jupiter and Saturn, or even on exoplanets far beyond our solar system. It's a humbling thought that across the cosmos, countless worlds might be silently crafting their own celestial jewels, hidden beneath layers of storm and ice. These ice giants, often overshadowed by their more colorful siblings, turn out to be cosmic forges, turning the humblest of gases into the most coveted of stones. Yet for all their extravagance, these diamond showers aren't just a spectacle, they're clues. By studying how carbon behaves under such extremes, scientists can piece together the inner workings of not just our ice giants, but all gas planets. The diamond's journey, their formation, their fall, their final resting place helps map the chaotic currents deep within these worlds, currents that generate powerful magnetic fields and drive titanic storms. In a way, these glittering hailstones are messengers, carrying secrets from the darkest, most pressurized realms we may never directly explore. Now, let's journey from the crushing depths of gas giants to a world where volcanoes defy every expectation, erupting not with fire but with ice. Pluto's frozen heart isn't just a metaphor, it's a geological reality, a landscape where volcanoes don't spew fire, but a bizarre slush of water, ammonia, and methane. These aren't your typical mountains, they're cryovolcanoes, and they've reshaped the dwarf planet in ways that defy everything we know about volcanic activity. Take Mons, for example, a towering structure nearly 3 miles high and 150 miles across, its sides wrinkled like the skin of an ancient, frozen giant. Unlike Earth's steep, conical volcanoes, right Mons sprawls with gentle slopes, its summit hollowed out by eruptions that oozed rather than exploded, leaving behind a cavernous depression where lava lakes might once have simmered. Except here, the lava was more like a frigid antifreeze slurry. What makes these eruptions possible in a world where temperatures hover around -230 degrees Celsius? The answer lies in Pluto's hidden heat. Despite its icy exterior, the dwarf planet likely retains enough internal warmth from radioactive decay to keep pockets of subsurface water mixed with ammonia, a natural antifreeze, in a semi-liquid state. When this slushy cocktail finds a weak spot in the crust, it bursts through, freezing almost instantly upon contact with the surface. The result, landscapes that look like they've been sculpted by a glacier with a temper, their surfaces puckered and ridged as the icy mixture piled up in slow-motion cascades. But here's the most thrilling part. Some of these cryovolcanoes might still be active. New Horizons images revealed a startling lack of impact craters on their slopes, suggesting these features could be relatively young, perhaps even recently formed in geological terms. If true, it would mean Pluto isn't the frozen relic we once thought, but a world with a slow, stubborn heartbeat, its internal heat still capable of reshaping the surface. Imagine standing at the base of one of these frozen fountains, watching as a plume of ammonia-rich water creeps through fractures in the ice, crystallizing into new landscapes before your eyes. It's a reminder that even in the farthest reaches of the solar system, geology never sleeps, yet the implications stretch beyond Pluto. If this distant, tiny world can harbor cryovolcanism, what does that say about the potential for activity on even smaller bodies in the Kuiper belt? And if these volcanoes are still erupting, what does that mean for the possibility of subsurface liquids and the tantalizing chance of life's ingredients being churned and mixed beneath the ice? Pluto's cryovolcanoes aren't just curiosities, they're clues hinting at a solar system far more dynamic than we ever imagined. Now, let's turn our gaze from these frozen fountains to a moon where the water isn't locked in ice. It's a vast, churning ocean, hidden beneath a shell of rock and stretching deeper than all of Earth's seas combined. Beneath Europa's fractured, icy shell, an ocean hides one that could hold more water than all of Earth's seas combined. This isn't just a frozen wasteland. It's a world where the cracks in the ice tell a story of hidden currents, of a subsurface sea churning under the pull of Jupiter's immense gravity. The surface is a labyrinth of ridges and grooves, like the shattered glass of a frozen windshield, but beneath lies a realm where the very conditions for life might be waiting. What keeps this ocean liquid in the cold depths of space? The answer lies in gravitational tug-of-war. As Europa orbits Jupiter, the gas giant's immense pull flexes the moon's core, generating enough heat to maintain a vast, salty ocean beneath an ice shell up to 15 miles thick. And where there's liquid water and energy, there's potential, especially when you consider the possibility of hydrothermal vents on Europa's seafloor. On Earth, these vents are oases of life, supporting entire ecosystems that thrive without sunlight, fueled by chemical reactions in the superheated water. Could similar vents on Europa be hosting alien microbes, or even more complex organisms? The idea isn't science fiction. Europa's ocean is rich in salts and organic molecules, detected in the plumes of water vapor that occasionally erupt from its icy surface. NASA's upcoming Europa Clipper mission aims to fly through these plumes, analyzing their chemistry for signs of biological activity. But the real breakthrough could come from a future lander, one capable of melting through the ice to send a probe into the dark waters below. Imagine the scene, a robotic explorer descending into an alien abyss, its lights piercing waters untouched by sunlight for billions of years. What might it find? Giant, blind shrimp-like creatures clinging to volcanic vents, strange microbial mats forming the base of an entirely foreign food chain. Or perhaps nothing at all, a sterile ocean, beautiful but lifeless. Yet even if Europa's waters are empty, the implications are staggering. A stable, liquid ocean this far from the sun challenges our assumptions about where life can exist. If it can thrive here, why not on Enceladus or Ganymede, or the dozens of other icy moons scattered across the cosmos? Europa isn't just a moon, it's a test case, a laboratory for understanding how life might emerge in the most unexpected places. And the mysteries don't stop at the water's edge. Europa's surface is streaked with reddish-brown scars, likely deposits of salts and organic compounds that have welled up from below. Some areas feature chaotic terrain blocks of ice that have been shattered, rotated, and refrozen, as if some enormous force beneath the crust reshaped the landscape like a jigsaw puzzle. Could these disruptions be caused by shifting ice moving over a turbulent ocean? Or are they evidence of cryovolcanism, where water erupts through the crust before freezing into new formations? One thing is certain, Europa is alive in a geological sense, its surface reshaped by forces we're only beginning to understand. And if life does exist there, it wouldn't be the kind we're familiar with. Any organisms in Europa's depths would have evolved in perpetual darkness, under pressures that would crush most earthly life, feeding on chemicals rather than sunlight. They might not even rely on DNA, perhaps using some other molecule to store genetic information. The possibilities are as vast as the ocean itself. Now, let's leave this world of hidden waters for a place where the air itself is thick enough to swim through, a planet where the atmosphere isn't just dense, it's practically an ocean of gas. Venus doesn't just have an atmosphere, it has an ocean of gas, a crushing, swirling mass of carbon dioxide so dense it would press down on you with 90 times the force of Earth's air. Standing on its surface wouldn't feel like walking on solid ground. It would be like trying to move through liquid concrete, with every step requiring Herculean effort. The heat is unbearable, reaching 460 degrees Celsius, hot enough to melt lead into puddles. And if that weren't enough, the sky doesn't just threaten rain. It unleashes sulfuric acid, a corrosive drizzle that evaporates before hitting the ground, only to rise and fall again in a perpetual toxic cycle. Yet for all its brutality, Venus holds a paradox. While its surface is a hellscape, its upper clouds tell a different story. 50 kilometers above the ground, temperatures and pressures eerily mirror Earth's, mild enough that a human could survive there with just a breath mask and protective clothing. Even stranger, those clouds contain mysterious dark patches, patches that absorb ultraviolet light in ways no known Venusian chemistry can explain. Some scientists speculate these could be signs of floating microbial life, organisms that evolved to thrive in droplets of sulfuric acid, riding the winds of a world that otherwise seems designed to snuff out existence. Imagine a biosphere not rooted in soil but suspended in the sky. These hypothetical microbes wouldn't photosynthesize like Earth's plants. They might metabolize sulfur compounds, turning the planet's deadly atmosphere into an energy source. And they wouldn't need to fear the acid rain, their very bodies could be adapted to use it, just as extremophiles on Earth thrive in boiling hot springs or radioactive waste. It's a radical idea, but not impossible. After all, Venus wasn't always a furnace. Billions of years ago, it might have had oceans, a temperate climate, conditions ripe for life to emerge before a runaway greenhouse effect transformed it into the scorched world we see today. Could some resilient organisms have retreated to the skies, clinging to survival in the only habitable zone left? The implications are staggering. If life can exist in Venus's clouds, it rewrites the rules of where we should search for it elsewhere. Gas giants with turbulent atmospheres, exoplanets with permanent cloud layers. Suddenly, they become candidates for floating ecosystems, entire food chains built around airborne microbes. Venus, long dismissed as a dead end in the hunt for life, might instead be a blueprint for how biology persists in the most unexpected places, but the real challenge is proving it. Future missions like NASA Da Vinci and ESA Envision aim to dive deeper into Venus's atmosphere, analyzing its chemistry in unprecedented detail. They'll hunt for organic molecules, strange isotopic ratios, anything that hints at processes we can't explain with geology alone, and if they find even the faintest whisper of life. It would mean the universe isn't just hospitable in rare, Earth-like oases, it's teeming with possibilities, even in the unlikeliest corners. Now, let's shift our gaze from this suffocating world to one where the spectacle isn't the planet, but what surrounds it. A place where the rings outshine their host, casting shadows so vast they'd eclipse continents. Saturn's rings aren't just a celestial decoration, they're a dynamic, ever-changing masterpiece of cosmic engineering. Picture floating inside this vast disk of ice and rock, where sunlight refracts through countless particles, each one glinting like a tiny diamond suspended in space. Some are as fine as dust, others as large as houses, all orbiting in perfect harmony, held in place by the delicate balance between Saturn's gravity and their own momentum. From this vantage point, the rings would stretch endlessly in every direction, a shimmering plane so thin that if you turned sideways, they'd nearly vanish, a cosmic illusion of grandeur and fragility combined. What keeps this intricate structure intact? The answer lies in a phenomenon called orbital resonance, where smaller moons like Prometheus and Pandora act as cosmic shepherds, their gravitational nudges preventing the rings from spreading out or collapsing. These moons carve gaps in the rings, creating dark bands that divide the ice into distinct regions, each with its own unique characteristics. The Cassini division, for instance, is a 2,900-mile wide gap so precise it looks sculpted by an invisible hand. But these aren't static borders. Particles constantly migrate, collide, and reform, making the rings more like a living river of ice than a permanent fixture. The origins of this spectacle are just as fascinating. One theory suggests the rings are remnants of a shattered moon, torn apart by Saturn's gravity billions of years ago. Another proposes they're leftover material from the planet's formation, debris that never coalesced into a larger body. Either way, they're surprisingly young by cosmic standards, perhaps only 100 million years old, a blink in geological time. This means that when dinosaurs roamed Earth, Saturn might have been ringless, and future civilizations could witness their slow disintegration as particles rain down onto the planet's atmosphere in a glittering, eternal shower. Yet the real magic lies in the details. Close-up images reveal textures like straw, clumps, and even propeller-shaped features caused by tiny moonlets embedded within the rings. Sunlight scatters through this icy maze in ways that still puzzle scientists, creating bizarre brightness variations and unexpected shadows. And then there's the spokes, mysterious dark streaks that appear and vanish, possibly tied to Saturn's magnetic field interacting with ring particles. It's a system so complex that after 13 years of study, Cassini's data is still yielding new discoveries. Now, let's shift our gaze from this delicate dance of ice to a world where fire dominates Jupiter's moon Io, a place where volcanoes outnumber cities and eruptions rewrite the landscape daily. Io isn't just a moon with volcanoes, it's a world on fire, a place where the ground itself is alive with fury. Imagine stepping onto a surface painted in vivid yellows, oranges, and reds, not from autumn leaves, but from vast plains of sulfur frozen into bizarre crystalline formations. Above you, plumes of gas and ash soar 250 miles into the sky, higher than any eruption Earth has ever witnessed. This isn't a postcard from hell. It's Jupiter's moon Io, the most volcanically active place in the solar system, where over 400 vents spew molten rock and sulfur in a never-ending performance of cosmic violence. What fuels this relentless activity? The answer lies in Jupiter's crushing embrace. Io orbits so close to the gas giant that tidal forces stretch and squeeze its interior like a cosmic stress ball. The friction generates immense heat, melting rock into vast underground seas of magma that constantly seek escape through cracks in the crust. Unlike Earth's volcanoes, which erupt sporadically, Io's vents are always active, some firing fountains of lava dozens of miles high, others oozing rivers of molten silicate that creep across the surface for hundreds of miles. The largest of these, Loki Patera, is a lake of lava bigger than Lake Ontario, its surface crust breaking apart and reforming in a slow, eternal cycle. But Io's eruptions aren't just bigger, they're stranger. Some vents blast sulfur dioxide so violently it escapes the moon's weak gravity, forming a ghostly umbrella of gas that rains back down as snow. Others spew lava so hot over 1,600 degrees Celsius that it glows blue in the darkness, a surreal contrast to the moon's sulfur-stained plains. The sheer variety of volcanic styles here is a planetary scientist's dream, offering snapshots of how Earth's geology might have behaved billions of years ago when our planet was younger and hotter. Yet Io's chaos isn't just destructive, it's creative. The constant eruptions recycle the surface every few million years, erasing impact craters and painting fresh landscapes in real time. Mountains taller than Everest rise and fall like waves, their slopes buckling under tectonic stresses no earthly range could withstand. And the moon's thin atmosphere, constantly replenished by volcanic outgassing, creates a fleeting envelope of gases that freeze onto the surface at night, only to be blasted back into space by morning. Could life exist here? Almost certainly not. The radiation, the toxic chemistry, and the lack of water make Io a dead end for biology as we know it. But as a laboratory for extreme geology, it's unparalleled. By studying how tidal forces shape Io, scientists can unravel the histories of moons like Europa and Enceladus, where similar heating might sustain hidden oceans. And for those daring enough to dream, Io's fireworks offer a glimpse of what volcanic worlds orbiting distant stars could look like, places where the forces of creation and destruction dance in perfect, furious balance. Now, let's leave this molten spectacle behind for a planet where the winds don't just howl, they scream, reaching speeds that defy the very laws of sound. HD 80606b doesn't just have winds, it has supersonic freight trains of gas screaming across its atmosphere at 11,000 miles per hour, speeds that make Earth's most violent tornadoes look like gentle breezes. This isn't just a stormy planet, it's a meteorological war zone where temperature swings of over 1,000 degrees Celsius happen in mere hours as the world whips around its star on the most eccentric orbit ever discovered. Picture the chaos. One side of the planet bakes under sudden, brutal heat, while the other plunges into frigid darkness, creating pressure differentials so extreme they ignite hurricane-force winds that could circle Earth's equator in less than 3 hours. What makes this world's weather so catastrophically intense? The secret lies in its cosmic dance, an orbit so lopsided it's more like a slingshot than a circle. At its farthest point, HD 80606b lingers at a distance comparable to Earth's position from the Sun. But when it swings close, it ventures nearer to its star than Mercury does to ours, roasting its atmosphere in a sudden stellar blast furnace. These wild temperature fluctuations don't just create winds, they supercharge them with hot gases rushing toward colder regions at velocities exceeding Mach 15. The storms born from this chaos aren't temporary, they're planetary-scale shockwaves, permanent features in an atmosphere that never settles, and the scale defies imagination. Jupiter's Great Red Spot could fit inside one of these tempests 100 times over, their cloud tops churning with turbulence visible from light years away. Infrared telescopes have actually detected the heat signatures of these megastorms, watching as the planet's day side flares like a cosmic alarm bell during its closest approach. Yet for all their fury, these winds aren't random, they follow precise patterns, curving into jet streams that loop around the planet in intricate braids, a mesmerizing mix of violence and order written in gas and heat. The real surprise, HD 80606b, might not be alone. Recent studies suggest that many hot Jupiters, gas giants hugging their stars, could harbor similar supersonic winds, their atmospheres stretched thin by stellar radiation until they flow like liquid metal across the planet's surface. Some might even rain molten iron, their night sides cool enough to condense heavy metals out of the sky. It's a reminder that when it comes to alien weather, the universe specializes in extremes we're only beginning to fathom. Now, let's trade this howling maelstrom for a world where the sky doesn't blaze with heat, but glows with an eerie, sapphire calm, a planet where sunsets paint the horizon in shades of blue. Mars doesn't just have sunsets, it has a daily light show that would make Earth's twilight seem ordinary. While our skies blaze with reds and oranges as the sun dips below the horizon, the Martian horizon glows with a haunting blue hue, as if the entire planet is bathed in the cool light of an underwater dream. This surreal spectacle isn't just a quirk of perspective, it's a physics lesson written in dust. The fine particles suspended in Mars's thin atmosphere scatter sunlight in the opposite way Earth's does, filtering out the warm colors and letting the cooler blues dominate the sky's palette. For any astronaut standing on that rust-colored soil, watching the sun shrink into a pale sapphire disk, the effect isn't just beautiful, it's a visceral reminder of how profoundly alien this world really is. But the magic doesn't stop at the color. Martian sunsets unfold in slow motion, their soft glow lingering far longer than on Earth. With the sun just 1/3 the size we're used to and the atmosphere 100 times thinner, twilight stretches into an extended farewell, the blue light diffusing across the sky like ink in water. And if you're lucky enough to be near one of Mars's towering volcanoes, like Olympus Mons, the shadow it casts isn't a dark smudge but a towering column of indigo, stretching hundreds of miles into the atmosphere as the sun sinks behind it. Could humans ever grow accustomed to this otherworldly rhythm? Future colonists wouldn't just adapt to the blue sunsets, they'd live under a sky that's pale pink by day, deepening to butterscotch during dust storms, then cooling to that signature twilight blue. The very cycles of light and dark would feel foreign, with the weaker sunlight casting sharper, longer shadows and the stars appearing not as pinpricks but as steady, unblinking points in the thin air. Even timekeeping would shift. A Martian day, or sol, is about 40 minutes longer than Earth's, meaning sunsets would arrive just a little later each evening by our clocks. Yet for all its strangeness, Mars's blue twilight offers something unexpectedly comforting, a connection to home. The phenomenon isn't entirely unlike what happens on Earth when volcanic ash filters sunlight after major eruptions, or when smoke from distant wildfires tints the moon an eerie copper. It's a reminder that even across the gulf of space, the same basic physics shape both worlds, just with wildly different results. And that duality, the familiar and the alien, woven together, might be the key to making Mars feel less like a hostile outpost and more like a second home. Now, let's leave this serene blue horizon for a moon where the sky isn't the main attraction, but what lies beneath it defies explanation. Jupiter's Ganymede hides a magnetic mystery deep within its icy shell, a puzzle that could rewrite our understanding of how moons form and evolve. Ganymede isn't just Jupiter's largest moon, it's a world with its own invisible shield. A magnetic field so strong it creates shimmering auroras that would put Earth's northern lights to shame. Picture standing on this icy giant surface where the sky isn't dominated by Jupiter's swirling storms, but by ethereal curtains of blue and green light dancing to the rhythm of invisible forces. These aren't just pretty lights, they're clues to one of the solar system's most tantalizing mysteries: what's happening beneath Ganymede's frozen shell. Unlike any other moon, Ganymede generates its own magnetic field, a feat usually reserved for planets like Earth or Mercury. Scientists believe this cosmic powerhouse stems from a molten iron core churning deep within the moon's heart. But here's where it gets even stranger: Ganymede's magnetic field doesn't just exist in isolation. It's locked in a constant tug of war with Jupiter's far more powerful magnetosphere, creating a chaotic zone where magnetic lines tangle and snap, releasing bursts of energy that ignite those spectacular auroras. It's as if the moon is whispering secrets in a language of light, revealing the hidden forces at play beneath its surface. And then there's the ocean. Buried under 90 miles of ice, a vast saltwater sea sloshes in the darkness, possibly holding more liquid than all of Earth's oceans combined. This isn't just water, it's an electrically conductive soup, rich in salts that might interact with Ganymede's magnetic field in ways we're only beginning to understand. Some researchers speculate these interactions could generate bizarre electrical currents, turning the moon's subsurface into a planetary-scale circuit. Could these currents even influence the chemistry of the ocean itself, creating pockets of energy where life might cling? The parallels to Earth's hydrothermal vents are impossible to ignore. Yet the most mind-bending part isn't what we know, it's what we don't. Ganymede's magnetic field is lopsided, stronger in some regions than others, as if something deep inside is distorting it. Is this asymmetry caused by uneven currents in the ocean, or might there be pockets of dense, conductive material embedded in the ice, acting like hidden magnets? Every new observation from spacecraft like Juno adds another piece to the puzzle, but Ganymede guards its secrets fiercely. One thing's certain: this moon is more than a frozen rock. It's a dynamic world where ice, water, and magnetism collide in ways that defy simple explanations. And as we prepare for missions like Juice, which will study Ganymede up close, we might finally unlock the truth behind its magnetic whispers and what they mean for the search for life beyond Earth. Now let's shift from this icy enigma to a planet where time flies at breakneck speed, a world where a single year flashes by in just 18 hours. PSR J1719-1438b doesn't just have a short year, it lives its entire life in fast forward. This bizarre world spins around its pulsar host in just 2.2 hours, a blink compared to Earth's 365-day journey around the Sun. But speed isn't the only thing that sets this planet apart. Imagine a place where the very ground beneath your feet is compressed into crystalline perfection, a diamond-rich remnant of a star that once was. This isn't science fiction, it's the aftermath of cosmic violence on a scale we can barely comprehend. The planet's story begins with destruction. Its host, PSR J1719-1438, isn't an ordinary star, it's a pulsar, the rapidly spinning corpse of a massive sun that went supernova. When that star exploded, it likely obliterated its original planetary system, leaving behind only this dense, carbon-packed survivor. Over time, the intense pressure and heat transformed the planet's carbon into a lattice of diamonds, creating a world that's less like a rocky body and more like a celestial jewel. But this treasure comes with a curse. The pulsar bombards it with lethal radiation, X-rays and gamma rays, stripping away any chance of an atmosphere or the faintest hope of life. Yet for all its hostility, PSR J1719-1438b is a goldmine for astronomers. Its existence proves that planets can form or survive in the most extreme environments imaginable. Even more intriguing, it's not alone. At least 5 other pulsar planets have been discovered, each with its own strange tale. Take PSRB 1620-26b, a gas giant so close to its pulsar that its year lasts just 6 months, or the infamous Hell planet, PSRB 1257+12c, where temperatures swing from scorching to freezing as it wobbles on its axis. These worlds defy every rule we thought we knew about where planets could exist. What's next for pulsar planet research? The hunt is on for more of these extreme survivors, with radio telescopes scanning the cosmos for the telltale wobble of a pulsar tugged by an orbiting world. Some scientists even speculate that pulsar planets could be more common than we realize, hidden gems in the universe's most violent neighborhoods. And while we'll never walk on their diamond crusts or witness their blistering sunrises, they remind us that the cosmos is far stranger and far more creative than we ever dreamed. Now let's shift from this high-speed world to a moon where the surface isn't uniform. It's split into 2 starkly different halves, like a cosmic yin and yang. Iapetus doesn't just have 2 faces, it's a cosmic paradox frozen in time. A moon where the line between light and dark isn't blurred but drawn with razor-sharp precision. One hemisphere gleams like freshly fallen snow, reflecting sunlight with blinding intensity, while the other absorbs light like charcoal, so dark it was nearly invisible to astronomers until spacecraft flew past. This isn't a subtle gradient or a weather pattern, it's a boundary so stark it looks like someone took a paintbrush to the moon's surface and split it down the middle. What created such an extreme divide? The leading theory points to an unlikely culprit, Phoebe, another of Saturn's moons. This distant, dark-colored satellite sheds dust as it orbits, creating a faint ring of particles that drifts inward over millennia. As Iapetus plows through this cosmic debris field, the dust sticks to its leading hemisphere, the side always facing forward in its orbit. Over billions of years, this slow-motion snowfall of soot has painted half the moon black, while the trailing side remains pristine, its bright ice untouched. But here's the twist: the dark material isn't just sitting there, it's changing the moon's geology. The darker areas absorb more sunlight, heating up just enough to vaporize nearby ice, which then migrates to the brighter, cooler regions. This creates a feedback loop, intensifying the contrast until the moon becomes a celestial yin-yang symbol. Yet mysteries linger. Why hasn't the same process occurred on other moons? And why does the boundary between light and dark follow such a precise, almost geometric line? Some researchers speculate that Iapetus's slow rotation, it takes 79 Earth days to turn once, plays a role, allowing temperature differences to stabilize the stark divide. Others wonder if ancient impacts or internal processes contributed to the moon's split personality. Even the dark material's composition raises questions. Spectral analysis suggests it contains complex organic compounds, hinting at chemistry more intricate than simple dust. Standing on Iapetus's surface would be like walking across a frozen chessboard. Step from the bright side into the dark, and the temperature would plunge as the sun's warmth vanishes into the Inkai terrain. The ice underfoot would transition from crystalline and hard to something softer, dust-choked, like walking on frozen coffee grounds. Overhead, Saturn would loom in silent grandeur, its rings slicing across the sky but only on one side of the moon. The dark hemisphere would offer a view of the cosmos unobscured by glare, stars shining with unnatural clarity against the void. This bizarre moon isn't just a curiosity, it's a lesson in how small, persistent forces can reshape worlds over time. Iapetus shows us that even something as simple as dust, given enough time, can turn a celestial body into a work of art, and it begs the question, how many other moons might hide equally dramatic secrets, waiting for us to look closer? Now, let's trade this monochrome masterpiece for a world where the skies don't rain water, they rain gemstones. On Hat P7b, the clouds shimmer with corundum, the mineral that forms rubies and sapphires, and when storms erupt, they unleash glittering showers that would make any jeweler's heart race. Hat P7b isn't just a planet, it's a celestial jewelry box, a world where the clouds shimmer with the same mineral that crafts rubies and sapphires on Earth. Imagine standing beneath a sky not of water vapor, but of corundum, the very substance that forms some of our most coveted gemstones. As temperatures plunge on the planet's eternal night side, these mineral-laden clouds condense into glittering droplets, raining down not water, but precious stones in a spectacle that would make even the most extravagant royal treasures seem mundane. What creates such an opulent downpour? The answer lies in the planet's brutal extremes. Hat P7b is tidally locked, meaning one side forever faces its star, broiling under temperatures hot enough to vaporize rock into a metallic haze. The other side, locked in perpetual darkness, cools just enough for corundum to crystallize out of the atmosphere, forming clouds that eventually shed their gemstone cargo. The physics is eerily similar to Earth's water cycle, except here, the rain is made of vaporized aluminum oxide, the mineral backbone of rubies and sapphires. And these aren't tiny specks. Some models suggest the droplets could grow large enough to resemble hailstones of solid gemstone before plunging into the planet's depths. But the real marvel isn't just the gemstones, it's what they reveal about planetary diversity. Hat P7b belongs to a class of worlds called ultra-hot Jupiters, gas giants that orbit so close to their stars their atmospheres are literally boiling away. Yet even in this inferno, nature finds a way to create beauty. The same stellar radiation that strips these planets of their outer layers also ionizes metals like iron and titanium in their atmospheres, creating exotic compounds that could paint the skies in vibrant hues. Some ultra-hot Jupiters might even have clouds of liquid metal or raining rubies, their atmospheres more akin to the crucible of a jeweler's furnace than anything we'd recognize as weather. Could such extravagance exist elsewhere? Almost certainly. The universe has already shown us planets with diamond cores, lava oceans, and glass storms. Why not ruby rains? In fact, Hat P7b might be the rule rather than the exception. As we discover more ultra-hot Jupiters, we're finding that their atmospheres are laboratories for chemistry we can't replicate on Earth, where familiar elements behave in alien ways under extreme heat and pressure. Corundum, for instance, might form in abundance on worlds rich in aluminum and oxygen, especially those with violent volcanic outgassing or impacts that churn up mineral-rich crusts. Yet for all its allure, Hat P7b is no paradise. The gemstone rain isn't gentle, it's likely a relentless, abrasive hail, scouring the planet's atmosphere as it falls. And the temperature gradients between day and night sides would create supersonic winds, hurling mineral particles across the sky in a glittering, corrosive tempest. Any spacecraft venturing here wouldn't just melt, it would be sandblasted into oblivion by the very beauty it came to study. But that's the paradox of these exotic worlds. They're both breathtaking and lethal, reminding us that the universe's most stunning creations often exist where life cannot. HTP 7b doesn't just expand our understanding of planetary science, it challenges our very definition of what's possible. If a world can turn its atmosphere into a gemstone factory, what other marvels, what other impossibilities might be waiting in the cosmic dark? From diamond planets to ice volcanoes, these 20 cosmic wonders reveal a universe that thrives on the impossible. Each one challenges our assumptions, proving that nature's imagination dwarfs our own. Who would have guessed that planets could rain glass, or that moons might hide oceans beneath miles of ice? These aren't just curiosities, they're invitations. Every bizarre landscape we uncover forces us to rethink what's possible, rewriting the rules of chemistry, geology, and even biology in real time. Think about what that means for the future. Right now, telescopes like James Webb are peering deeper into space than ever before, spotting worlds where the skies burn with metallic vapors or the very air sparkles with diamond dust. Missions to Europa and Enceladus could soon drill through ice in search of alien life, while probes might one day skim the sulfuric clouds of Venus, hunting for those mysterious dark patches that could hint at floating microbes. The discoveries we've made so far are just the prologue, and here's the most thrilling part: we've barely scratched the surface. For every exotic world we've catalogued, there are billions more waiting in the dark, each with its own secrets. Some might harbor life in forms we can't yet conceive. Others could rewrite physics itself, with conditions so extreme they bend the laws of nature. The universe doesn't just have a few oddballs, it's a gallery of the unimaginable, and we've only glimpsed the first few exhibits. So what's next? That's up to you. Every like, share, and comment fuels the conversation, reminding us that exploration isn't just about robots and telescopes, it's about people. Your curiosity is part of this story. Maybe you'll be the one to spot the next breakthrough in a data stream, or inspire a future scientist to chase answers we haven't even thought to question yet. The cosmos is vast, but it's not unreachable. It's out there, waiting, and every new discovery brings it closer. Thanks for joining this journey across the universe's most mind-bending landscapes. If you have a favorite alien world, drop it in the comments. We'd love to hear which one captured your imagination. And if you're hungry for more cosmic wonders, hit subscribe so you don't miss what's coming. Until then, keep your eyes on the skies. The next great discovery might be just over the horizon.